got a moment about point C of 180,000 I minus 36. Is that, oh, it's plus. J minus 150,000 K, and this was in Newton millimeters, right? And from the vectorially, we got the answer to be negative 180I plus 36J minus 150K Newton meters. They're the same, right? We have the same answer both ways. And then how do we find out, remember, okay, what were the three ways that vectors can be represented? From the beginning of the semester, three ways. One is magnitude and direction angles, right? So the three ways were three ways to represent a vector. You guys over there? One is in vector form. One is magnitude and unit vector. And the other way is magnitude and direction angles. And what's direction angles? What are those guys? Theta x, theta y, theta z. Okay? When we represent moments, moments are used this way and this way. We don't usually use unit vectors. So it's very, very much like resultants. When we found resultants, we represented them in vector form and magnitude and direction angle. So Mark told us how to get the magnitude. We did 180 squared plus 36 squared plus 150 squared, and it came out to be, was it 237?
Yeah.
Newton meter. How would I find the direction angles? So Chris, we're up to you. So we found the x, y, and z component of the moments, and we found the magnitude of the moment. How would I find the direction angles?
Using trig.
Tell me which one. Yes, you're right.
Like inverse tangent.
Inverse, not tangent,
Cosine.
but cosine. So the inverse cosine of the moment about the x over the moment. Right? Remember I said whenever I ask you a question about moments and you're not sure, think of it in terms of forces. Because in order to find the direction angle in a force, it was the inverse cosine of the force x over the force. So it's the inverse cosine of 180 negative over 237. And then we do these two. And let's see what values I got. You might have to calculate it because I never, when I pull the sheets out, I forget where I put them.
There could also do tan inverse of the y component over the x component.
You don't, typically you don't want to do that. The main reason you usually don't do it is because one of these, this is usually what you're given. Like in terms of forces, you're usually given the main force and you found the component, so it's better to use something that you were given. In this case, I guess it really doesn't matter because you calculated everything. But remember, it goes back to why do we always use cosine? Because we're really doing dot product. So I guess you could do it with tangent if you wanted. I don't have the values. I can't find them. What'd you get?
139 plus 0.4.
139.4. Did somebody else get that?
Yeah.
Okay, what's the y?
81.3.
Did somebody else get that?
Yeah.
And the next?
Yep.
129.3. Did somebody else get the 0.3?
Yeah.
Yeah. Okay. Just leave that on for a minute, Kyle. So just one last thing that Evan asked me. At the beginning of whether you do right-hand rule or vectorially, you need to find the components of the force. Because this problem, they gave us a force of, what was it, 735 or something? 735 newtons. That's all they gave to us was the magnitude. In order to do right-hand rule or vectorial, we have to find the components of that force first. So the first thing is you find the components of the force, and then you do it vectorially, and I'm using right-hand rule. So I gave you a problem here. We did one problem in class. There's one problem on the sheet, and then you could go ahead and do your homework now. You could do the 3D homework, which is homework number 6, which I sent you the solutions already. So you have a lot of practice, and you've got to start practicing. On Tuesday, today's Thursday, right? On Tuesday when I see you, we're going to be doing more 3D stuff, and you're going to get more in-class practice doing 3D right-hand roll. But we're kind of moving on to a different topic. It's moments about lines and couples, but we're still doing 3D right-hand roll. From now on, we're only doing 3D right-hand roll. We're not doing vectorially. Because vectorially just gives us a bunch of numbers shooting out of the calculator without us really understanding what's going on. We take a look at this camera here. This camera, when Kyle tweaks that arm that he's holding, it's going to create a different force. And that force is going to create a different moment on these possible legs or on the bars that are between the legs. And we need to be able to physically look at that and say, oh, that whole contraption there is going to rotate towards Jill and knock her in the head. And we want to make sure that doesn't happen. Well, if I'm going to have to sit down and do everything vectorially with matrix, I do not have a physical feel of protecting Jill. But if I have a good feel of right-hand rule, I can figure out which way it's going to fall. Okay? Okay, move your exams back. Isadora. Oh, and